All right. So I'm assuming by now you've at least solved these over here. So we're going to try another type of proof by induction, that is not a summation, right? And this is prove the follow proof using principle of mathematical induction that 4n minus 1 is divisible by 3. Let me just counter check this to counter check whether this is actually the this is the, so it's 4 to the power n. Yeah, so it's 4 to the power n, not 4n. That would have been, well, would have wasted a few minutes solving a question that's wrong. But it's 4 to the power n. Prove that 4 to the power n, like that. So prove that 4 to the power n minus 1 is divisible by 3 for all n which are greater than or equal to 1. So how do we do this? So first of all, we know that we have 4n minus 1, right? 4n minus 1 basically means, remember when you said if a number is divisible by 2, then it can be expressed, so if a is divisible by 2, then it can be expressed in the form 2 by some integer n, right? So if it's even, so in this case, if it's divisible by 3, then it can be expressed in the form and this is the form 3 by some integer r. So mean it can be divided by 3 r times, right? So how are we going to use this to our advantage? Well, first of all, we're going to start off with our proof, right? So first of all, we're going to show for 1, right? We show for the lowest that n can be, which is 1. So if I say 4 to the power 1 minus 1 is equal to, this is just 3, which is in the form 3 to the power r. So this works. So therefore it is valid for n is equal to 1. Now we start our induction. So our induction actually starts, and then here it's the same procedure we used for the previous one. So what are we going to do? We're going to say assume n is equal to k is valid, right? Assume n is equal to k. So we're going to have 4 to the power k and 4 to the power k minus 1 is equal to 3 by some integer t, right? So we assume that, okay, this guy for k, it's also divisible t times, right? So if we say 4k, then it's divisible t times. Now prove n is equal to k plus 1. So how we're going to do this one is say 4 to the power k plus 1 minus 1. Now this over here, so this is where our proof actually starts from. This over here can be expressed as 4 to the power k by 4 minus 1, right? Which will then give us, now we already know what in fact, before we even jump this, I skipped one step. So what we're gonna do here now is to say, okay, we have this over here, right? So now let's solve for 4 to the power k. So 4 to the power k is equal to 3t plus 1 there, right? So now prove n is equal to k plus 1, and this can be proved by saying, okay, 4 to the power k plus 1 minus 1 is equal to 4 to the power k by 4 minus 1. Now this, then we can then come in and say, okay, we know what 4 to the power k is here, so we solve for 4 to the power k, which is 3t plus 1, all this by 4 minus 1, which will then give us 3. So if we multiply through, what we'll have 3, then 4 by t, like that there, right? Then plus 4 minus 1, which will then give us 3, then 4 by t plus 3 there, right? So if we have that there, we can then of course factor out the 3 on both terms. So we're going to have 3, then we're going to have 4t plus 1. This is an integer, right? So it's a direct proof we've been doing all along. So it's an integer. It's going to have 3s. Now what does it show? This shows, therefore this shows that 3s is divisible. This shows that n is equal to k plus 1 is divisible by, so it shows that this is divisible by 3, hence proven. So we've proved using induction. So yes, sorry for my handwriting. Yeah, but we've proven using induction just like that. So that's how you go about this kind of proof.